Welcome to section 4.5, absolute maxima and minima. Our goal today is to find absolute maxima or minima on open and closed intervals. So the definition of an absolute max or min is that if our function at a value is greater or equal to our function for all of the x in our domain, then that point is called the absolute maximum. So it's the highest point on all of the graph. All the other points fall below it. If it's the opposite case and it's less than all the other parts of our function, then we call it the absolute minimum. So before we were looking at local max and local min, now we're looking at absolute. So over the whole function, is it the highest or lowest point? Some of our theorems: a function that is continuous on a closed interval has both an absolute max and an absolute min because it's closed. So we can see over the whole course of the function, it'll have a maximum and a minimum. Absolute extrema, if they exist, must also occur at critical values or at the endpoints. And we can use a second derivative test. So if f is continuous on an interval and it has one critical value, then if we take the first derivative and it's 0, and the second derivative it's greater than 0, so it's positive, then that means that point C is the absolute minimum of f. If our first derivative is 0, and our second derivative is negative, then f of c is the absolute maximum. So that's our second derivative test we can use. The procedure for determining our absolute extrema is going to be to check to make sure f is continuous, find our critical values on our interval, evaluate the endpoints, so a and b. The absolute max is the largest value that we find between our endpoints and the critical values, and then the absolute minimum is the smallest value. So we'll look at all of our critical points and the endpoints and determine what's the highest and what's the lowest values. Find the absolute maximum and the absolute minimum for the given function on the interval. F of x equals 7x squared minus 14x plus 5 on the interval from -2 to 5. So first, let's find the critical values of our function. So we'll take our derivative. 7x squared is 14x, minus 14x would be minus 14, and plus 5 is 0. And our critical values are where this equals 0. So 14x equals 14, x equals 1. And then we want to calculate the function value, not only at this critical value, but at the endpoints as well. Calculate our function Okay, so the endpoint was -2, so we'll find f of -2. We have 7 times -2 squared minus 14 times -2 plus 5. That will give us 28 plus 28 plus 5, 61. We'll have f of 1, which is our critical value, 7 times 1 squared minus 14 times 1 plus 5. So we have 7 minus 14 plus 5, -2. And our other endpoint, f of 5. 7 times 5 squared minus 14 times 5 plus 5. So we'll have 175 minus 70 plus 5. This gives us 110. So based off of this information, we can see the absolute maximum is at 110, and the absolute minimum is at 1, -2. Okay. In problems 2 to 3, find the absolute maximum and the absolute minimum if either exists. So, f of x equals 5x cubed minus 6x to the 4th. Again, let's find our critical values. So we'll take our derivative. 5x cubed is 15x squared. 6x to the 4th is going to be 24x cubed. Our critical values are when this is 0, so let's factor 3x squared out. We'll have 5 minus 8x. So if 3x squared equals 0, x will equal 0. And if 5 minus 8x equals 0, then we've got negative 8x equals negative 5, x equals 5/8. So we have two critical values now. Let's use our second derivative test on our critical values. So we'll take our second derivative. 15x squared is 30x, and 24x cubed is going to be 72x squared. So let's test the first one. 0, 30 times 0 minus 72 times 0 squared gives us 0. And the second one, 5/8, will be 30 times 5/8 minus 72 times 5/8 squared. This will give us negative 75/8. And so our second derivative test fails at 0, but it tells us that there is a local max at 5/8. So that's important for us to know. Let's calculate the function values at these critical values. So at 0, our function is 5 times 0 cubed minus 6 times 0 to the 4th, so 0. And f of 5/8 at that point will be at 5 times 5/8 cubed minus 6 times 5/8 to the 4th. 5 times 125 over 512 minus 6 times 625 over 4096. This will give us 625 over 2048. Now we can see between 0, 625 over 2048, the maximum is obviously at 625 over 2048. So the local maximum is at 5/8, 625 over 2048, and the local minimum is at 0, 0. our 0.58 and 625 over 2048 is also the absolute maximum. Because we found the other, this one is our highest point across the function. There is no absolute minimum. Okay. F of x equals x squared minus 5 over x squared plus 2. Let's find our critical values. Taking our derivative, we have the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And we can simplify this to 14x over x squared plus 2 squared. Now, when this is equal to 0, that means 14x is equal to 0, so x equals 0 is our critical point. Now, to determine if this is a maximum or a minimum, we are going to use our second derivative test. So we'll take the second derivative. We've got the bottom, which I'm going to rewrite before we start this process. I'm going to multiply that out. So we have x to the 4th plus 4x squared plus 4. Okay, so now when we take our second derivative, we have the bottom times the derivative of the top minus the top times the derivative of the bottom over, oh, that's not the derivative of the bottom. The derivative of the bottom, it's going to be 4x cubed plus 8x over the bottom squared. X to the 4th plus 4x squared plus 4 squared. And we can multiply these out. Negative 42x to the 4th minus 112x squared plus 56 over x to the 4th plus 4x squared plus 4 squared. And we're testing when x is 0. So we're looking at our second derivative test at 0. Negative 42 times 0 to the 4th minus 112 times 0 squared plus 56 over 0 to the 4th plus 4 times 0 squared plus 4 squared. This is going to give us 56 over 16, 7 over 2. That is greater than 0, so we have a local minimum. 0, negative 2.5, I'll write it, is a local minimum and an absolute minimum. there is no absolute maximum. Okay, find the indicated extremum of each function on the interval. The absolute minimum on 0 to infinity for f of x equals 6 plus 2x plus 7 over x. Let's find the critical values. Our derivative of 6 is 0, derivative of 2x is 2, derivative of 7x to the negative 1 will be negative 7x to the negative 2. And I'm going to rewrite this as 2 minus 7 over x squared, just so we don't have a negative exponent. Our critical value is when this equals 0. So we'll have 2 equals 7 over x squared, 2x squared equals 7, x squared equals 7 over 2, x equals root 7 over 2, which is approximately 1.87. Let's use our second derivative test to find out if this is a maximum or a minimum. So our second derivative of 2 is 0, and the derivative of negative 7x to the negative 2 is going to be 14x to the negative 3. We're checking our point 1.87, so 14 times 1.87 to the negative third is about 2.14. This is positive, so we have an absolute minimum. And if we plug that into our function, we'll get 13.48 just about. Okay. We want to find the absolute minimum value on the interval 0 to infinity for f of x equals 10x squared minus 8x plus 26. Our critical values: derivative of 10x squared, 20x, derivative of negative 8x, negative 8, derivative of 26 is 0. When this is equal to 0, 20x equals 8, x equals 8 over 20. We can write that as 0.4. So let's use our second derivative to test this. The derivative of 20x is 20, and the derivative of 8 is 0. So if we test 0.4, it will always be 20. This is positive. So the point 0.4, if we plug that into our function, we'll get 24.4 is an absolute minimum. And we want to find the absolute maximum value on the interval from 0 to infinity for f of x equals 3x to the 6th minus 18x to the 4th. Our critical values: take our first derivative, 3x to the 6th will be 18x to the 5th, And 18x to the fourth will be 72x cubed. When this equals 0, let's factor out the 18x cubed. So we'll have an x squared minus 4. If 18x cubed equals 0, x equals 0, and if x squared minus 4 equals 0, then x squared equals 4, so x will equal positive or negative 2. Now, this is where we need to pay attention to our interval because x being negative 2 is outside of our interval. Our interval is from 0 to infinity. So we're not going to even look at x equal negative 2. So let's check, using our second derivative, the value of 0 and the value of positive 2. Actually, we don't even have to do 0 because it's not including 0. So we only have to check positive 2. Hooray! Okay, so our second derivative of 18x to the fifth, 90x to the fourth, derivative of 72x cubed, 216x squared. Let's check the value of positive 2. 90 times 2 to the fourth minus 216 times 2 squared. This will give us 1,440 minus 864. So 576, which is positive. Therefore, the point 2, and if we plug 2 in, we get negative 96, is the absolute minimum.